Good day, ladies and gentlemen. It's Mr. Nambane once again. Thank you very much for all the support you've been giving to us. We have videos out on momentum, which is topic number 1 of physical science, grade 12 syllabus. And we are currently busy now with topic number 2, which is vertical projectile motion. We already have a video before this one. So in that video, it's basically where we explain all the concepts and basic concepts of vertical projectile motion. So before you watch this one, kindly go back and watch that video, because it is going to assist you in terms of understanding which approach we'll be using when we tackle such problems. So in that video, we did type 1 and type 2 kind of problems. So with this one, the aim is to look at type 3 and then look into a bouncing ball. But one will ask, what is now type 3? So type 3, it's now when you have a situation where your projectile is thrown up and hits the ground. Okay, let's say first it passes the starting point, and hits the ground. So what it does is it's thrown vertically up, passes now the starting point, and eventually it hits the ground. So can I have a drawing for kind of this situation? Yes, I can be able to say I have now my starting point or a certain height, and then I can also be able to say it will hit, now this will be my ground. So what is it that actually is being said here? It is that my projectile will now move from the starting position, go up, reach the maximum height, pass the starting point, and now eventually hits the ground. So this is basically type 3 of a question. So in us approaching this question, what we do is we break it down into few portions, because already we worked with an object that is thrown up, reaches the maximum height, and then it returns now to the starting position. So but now in this case, this one is passing the starting position. So we are going basically to extend it further in terms of what happens when it passes the starting point. So I will still do my labels where I have A, where I have B, where I have C, and then the final one will now be D. So I'll write it here. The final one will be D. D. So now basically what is it that is happening? We did say now for the motion of A to B. In the previous video, we agreed that now V initial decreases as we approach the maximum height. So I'll have to emphasize it again that for maximum height, V initial decreases as we move towards that. So let me emphasize, as it approaches the maximum height. But now what happens at C? At C is the part where we explained that at C, I will edit also here as number 2. At C, V initial at A is equals to V final at C. And then we did explain that our delta Y here will be equals to 0 with reasons stipulated in the previous video. Then what happens now at D? At D, we have now VF increases as the projectile approaches the ground. Approaches the ground. So this basically says our principle of window still applies, where we said now with window is that velocity increases as our object is moving down. So this is now our principle or analogy that we use. So VF increases as the object approaches the ground. So I might need to highlight a few things. The reason for breaking it down in such a manner is for me to be able to attend to each and every individual path independently. So it says I can be able to work with A to B and then B to C, or even C to D. So depending on the information that is given, I will be able to specify exactly which path I'm looking at, which information is given to me. So I can easily say now, let's add now at B, we know that our maximum height. So if it's our maximum height, then we know that V is equals to 0 meters per second. Kindly check that I am saying V, I am not saying V initial, V final, because of it will depend now on which path are you looking at. If I'm looking at A to B, then VF at B, I will have now my final velocity. But if I'm looking at the motion of BC, then it means I am talking about V initial, which will be equals to 0. Hence, I don't want to commit and say this is V final or this is V initial. So the idea for that is basically us looking at the path that will assist us in getting the correct answers. So to emphasize more of this, we will need a question that we can use as a practice in order for us to answer now the questions that follow. So there's a question here that we have. It says, question 3, a situation where we have a ball that is thrown up, passes the starting point, and hits the ground. So they further say now, a boy fires a pellet gun upwards from the top of the building. The pellet leaves the gun at 20 meters per second and strikes the ground at 30 meters per second. And what is important is ignore the effects of air resistance. So I definitely know from the statement that I should ignore effects of resistance, it automatically says to me then the only force that is acting on this object or the pellet can only be the force of gravity. Then I will be able to answer my questions correctly. But remember, as hint number 1, we said I will need now to draw a situation or the information that is given, because my trajectory that I'm going to draw will assist me in terms of ensuring that I get everything right. So I will just draw the ground here, and then I will draw now the path of the pellet gun. So it was fired upwards. So I'm going to say here, I have this part, it was fired upwards, and then it eventually hit the ground. Can I assign my A, B, C, D? Yes, I can. I can say this is A, this is B, then I have my C there, and then I will have my D as well. So let's assign the information given. I am being told that its initial velocity is 20 meters per second. So I'm going to write the information I have at A. So I am told at A that V initial is equals to 20 meters per second. This is just me analyzing the statement that is given. And then I am told again at D, it strikes the ground at a velocity of 30 meters per second. So I am told now that V final here is equals to 30 meters per second. What other information do I have? I don't have any other information, but I believe I have exhausted the statement that is given. But remember, we are working with vector quantities here, so it is always advisable to indicate the choice of direction. So I'm going to choose now up as positive. So I will be able to answer and look into the questions that are given. So the very first one at 3.1, it says now, calculate the height at which the pallet was shot. So basically they are asking us to find now the height between C and D. So now this is the first question. So what information do I know? It depends. You can either do it for the path A, B, C, D, or you can only look at CD. Hence, I say it is always best now to specify which motion or which path are you looking at. So if I am looking at CD, I know already that my displacement here from A, B, C will be now what? Will be 0. That is the reason why we had to start with type 2 questions. So I already know that whatever I do, then if I have some enough information on C to D, then I can easily be able to answer that. Either way, I can start now from A, B, C, D. So this is just me explaining in terms of which path I am looking at. So I'm going to try and do it in twofold, such that we understand why it's so important to draw your trajectory or your sketch of the problem that is given. So I will say now at 3.1, let me write my data, or for which motion I am looking at. I am looking from A now to D. So from A to D, what is it that I have? I am looking for delta Y. Do I have VI? Yes, I have VI. It's upward. It is 20 meters per second. Do I have V final? Yes, I have V final, which is equals to minus 30 meters per second, because now it is moving downwards. What else do I have? I know that G will always be given, and G is 9.8 meters per second squared, and then it is always downward, so I will have my negative also. I don't have time that is given, so, and I need only 3 variables, so this will somehow be able to assist me. Then I can easily go to my formula sheet and use VF squared is equals to VI squared plus now 2G delta Y. Then I can do my substitution. This one is minus 30. I can do now 20 squared plus now 2 minus 9.8 multiplied by delta Y. I will eventually get my answer as 25,51 meters. So the height there is equals to 25.51 meters. So this is approach number 1 when I look at motion from A to D. So I'm going to try again and explain it now in looking at the motion from C to D. So now I am going to do it for, let me remove this. I am going to do it for the motion of A to C to D. So I'm going to say now for C to D, this is what I am looking at. Due to symmetry, I know that I have my V here at C, which is also equals to 20 meters per second. That is now from symmetry, or the videos that we did, we explained in detail why it should be 20 meters per second. So if you check for CD, I already have the same data, but the only thing that will change now is the direction. So I will still use the same equation, VF squared, which is equals to V initial squared plus now 2G delta Y. Then my V final, it will be negative 30 squared, which is equals to now minus 20 squared, because at C, now my object is moving downwards, hence I have the initial velocity as 20. Then I will still have plus 2, which will give me minus 9,8, and then multiply by delta Y. Multiply by delta Y. So doing the calculations, we should get the same answer, delta Y. We should get the same answer where delta Y is equals to 25,51 meters. And then we say now the height here should also be 25.51 meters. So it's just an approach that one can use. It's just an approach that at least now you know what is it that you have and what is it that you are working with. So I want to add this question just to modify it and understand it correctly. So I'm just going to write it here before we calculate the time taken. Now let's calculate the height of pellet above the ground. So I'm just adding this one just to be able now to emphasize what is happening here. So CD, it's now the height at which the pellet was shot, but I want to know above the ground what is the maximum height that the pellet was at. So I'm going to add that just for us to be able to understand exactly what is happening. The displacement for ABC is 0, but now I want the height at the pellet was at B. So I am looking for that when I am addressing this particular issue. So I need to be specific now. Which motion am I looking for, or which part of the path? I am looking for A to B. So when I'm looking at A to B, I have my delta y, which is what I am looking for. And then I have my V initial, which was given as 20 meters per second. I have V final, which is now 0 in this case. That is me now looking at the motion between A and B. Then I have my G, which is always given, that is 9.8 meters per second squared. Time I don't have, but now once I have my 3 variables, I can easily go back and choose an equation that I can use. So V squared is equals to V initial squared plus 2G delta y. Then this one is given, it's 0. This is 20 squared plus now 2 multiplied by 9.8 delta y, but my 9.8 must also be negative because the object is moving upwards. Then I finally get my delta y as 20,4141 meters. So it's me trying to explain fully what happens here. So I can easily get the correct answer if I exactly understand which path should I be working with. So we said this one is 24,41 meters. So I am happy with that, but now this is the height from A to B, or the displacement from A to B. So for me to get the total height above the ground, height above ground, then it should be 25,51 plus now 20,41. So this will give us something like 45,92 meters. So this will assist us when we get to the graphs, because when we get to the graphs, it's when now we will be expected to give values. We will be expected to explain certain positions in the graph of exactly what happened. So we'll now need to move to question 3.2. 3.2. So I believe now everything was done the right way. The only thing now is for us to add a second page, then we'll be able to continue with this problem. So to create space, let me just delete everything here. Let's delete everything here, and then we will be able to write something as well. But I am not going to remove our sketch because we are still going to need that in order for us to answer the questions thereof. So we are at 3.2. So at 3.2, we look now for the motion of AB, because they're saying now calculate the time taken for the ball or for the pellet to reach the maximum height. So it will be for the motion for A to B, because we are looking at it reaching our position B then. So it's easy to say we have VF at B, which is 0 meters per second. And then we have V initial, which was given to us as 20 meters per second. Do we have G? Yes, we know G, it's 9.8 meters per second squared. minus. Then we can choose the correct formula that has t in it, because we don't have delta y unless you use the delta y that we added into this. Then it will be easy for us to say v final is equals to v initial plus now plus now gt plus gt. So plus gt, where now v final is equals to 0, v initial is 20, plus now minus 9.8 t. And then when we do the mathematics, we'll find that t is equals to 2.04 seconds. So now this is the time only from A to, so we have 2.04 seconds. So this is the time from A to B. So with symmetry, I know that now the time from A to B is equals to the time from B to C. So they are asking me now at 3.3, calculate now the time taken to hit the ground. So the motion that I'm going to look for is for the motion, or the part of the motion, which is now CD. So when I look at CD, that is now 3.3. When I look at CD, this is now for CD. So when I look for CD, what I have is I have my V initial, which is minus 20 meters per second. Remember, because of the direction and symmetry. I have my V final, which was given as now 30 meters per second. That is now also minus. And then I have G, which is minus because it's moving downwards, which is 9.8 meters per second squared. Can I calculate now for T? Yes, I can. I can use now VF is equals to V initial plus GT, which will be now minus 30 minus 20 plus now minus 9.8 T, minus 9.8 T. And then when I solve for T, I'll find my T as 1.02 seconds. So the question wanted now time taken to hit the ground. So it means I must now get the total time taken from A, B, C, D. So my total time should be equals to, from A to B, I have 2.04 plus B to C, I have another 2.04, and then from C to D, I have 1.02. So 1.02. Then my total time here, the sum of it will give me something like 5.1 seconds. So there are many ways of doing it. The only way is which approach do you understand best. Hence I said the only thing, if we want to get it right, it's let's break it down into sections. Let's break it down into paths that we are able to associate the calculation with. Because I can easily say, what if I was looking now for the motion of 4A to D? Will I still be able to get it right? Yes, I can. But now when I look at that, my data will be VF. It's minus now 30 meters per second. V initial is the 20 that was given, 20 meters per second. And then my G is 9.8 meters per second squared. Then I can easily use the same equation again. VF is equals to V initial plus now GT. Then I will have my minus 30, which is equals to 20, and then plus minus 9.8 t minus. Then when I do my mathematics, I will solve for it, and then I will eventually get something like 5.1 seconds. So it entirely depends on to you. But obviously, the key idea here now should be what? Should be one, understanding what is expected of them in terms of approach. So the approach is general, so it entirely goes with how best do you understand the problem or the question that is given to you. So hence I always try to show you other ways of doing it. We cannot be programmed as to say this is how we are going to approach vertical projectile, but it will always be a form of you being able to draw your sketch, and then from your sketch you just manipulate the information that is given, and you will probably get it right. So I'm going to copy this such that we can be able to answer 3.4 as well as 3.5. So let me quickly copy, and then we will be able to continue with 3.4, 3.5, and eventually 3.6. So at 3.6, they are saying now draw a graph of position versus time. So I will have to clean up my board so that we can draw all the graphs that we need to draw. Let's draw the graphs that we need to draw. Okay, let's remove all this, and then now we are ready to draw our graph. Then they are saying here, draw a graph of position versus time. So for us to draw position versus time, there are two things that we need to understand first. It will depend on which reference point is it given to us. So I'm going to draw two graphs, but now the reference is what is changing. So kindly understand that at times the examiner will be specific to say, use the ground as reference, use the height of the building as a reference, or depending on which information is given. But somehow for the position versus time graph, you will be expected to have now a certain reference that one can use. So you're going to be expected to have a reference of how your graph should look like. So if the reference is wrong, at some stage, in most cases, you will always get it the wrong way around. So I'm going to draw the first one. Let me have my axis. Let me have my axis, and then I can also draw my axis this side. The second one there, right? So we all know that we need to have our axis. So this one, it will be position in meters, and then this one will be now time in seconds. So this one that I'm going to draw here, I'm going to use height of the building as reference. So height of building as reference. Fine. So if I'm going to draw this graph using the height as reference, so it means it should start at 0, move now up, reach a certain maximum, and then drops to a certain height, and then now pass the building and then hits the ground. So basically all it says is this part here where I have my time axis, I can refer to it now as the building when I am asked to draw it as building as the reference. So can I label my graph? Of course I can. So if I label my graph, I will know that only up to here it covered something like 20.41 meters. How long did it take to reach the maximum height? We calculated that it took something like 2.04 seconds. Then with symmetry, I know now this should also be 4.08 seconds. And then somewhere here, let me extend it further, then I will be able to get my 5.1, which was taken to complete the path. Now this is a D. Can I assign my labels? Yes, I can. I will have my A, B, C, as well as D. But now I know at D that my final displacement there that was covered was something like 25.51. So 25.51. So this is now when the height of the building is used as a reference. Then we further move on to say, what if we are told that the ground now is reference? So told that now use the ground as reference. So when I am going to use my ground as reference, it says my graph cannot start at the ground because we said my x-axis will now represent my reference in this case. So it did not start at the ground. So what does it say? It must end at the ground. So it started somewhere above the ground, and now it started at the height of 25.5. So this height here is 25.51. That's now the height of the building. It went up, reached a certain maximum, and then started now to fall back. So what is this value here at the top? This value at the top is our final displacement that now it covered, or the height above the ground. So we calculated this as 45.94 meters. Then it took something like 2.04 to cover the distance, and then it took something like 4.08, and then eventually 5.1. So this is my time axis in seconds. Can I assign A, B, and C? Yes, I can. I have my A, I have my B at the maximum height, I have my C, I also have now my D. So it will entirely depend on what information is given to us, which information did we calculate. So from that information it's easy. We will be able to draw now our correct graphs. So it's easy only if you understand what is referred to when they say use the height of the building as reference, and then use now the ground as reference. Then 3.5, they are saying now draw a graph of velocity versus time. So with velocity versus time, it will be easy to do because all the values of velocity versus time were given. So I knew that it started now with a velocity of 20 meters per second, 20. Then it went up, approaching B. So when it is moving up, remember the velocity of the projectile decreases. And then from B to C, it reached a certain value. And then at C, it further went on to reach now D. Can I label my graph? Yes, I can. I have this point here, which is A, maximum height, which is B, at C, and then I can further explain it as D. So it says at C, the velocity here, according to symmetry, it must also be 20 meters per second, just in an opposite direction. Then the final velocity here was also 30 meters per second. So this is my velocity, and then this is now my time in seconds. So how long did it take to reach the maximum height? It took something like 2,04. How long did it take to reach point C? 4,08 seconds. And then it took something like 5.1 seconds to complete its motion. So this one becomes now velocity versus time. Velocity versus time. The last one, which is 3.6, draw the graph of acceleration versus time. So with acceleration versus time, I will just add it here at 3.6. We have our acceleration versus time. So we know that acceleration versus time, in this case, we said our upward is positive, so it means our g is negative. So I will have my value here, which is 9.8. Remember, it's just a constant. Then it will be the same throughout until we reach 5,1 seconds. So this is now time in seconds. And then this is acceleration. And then that is our time. So this is a question that I feel that if you understand the basics from here, then you will be able to do a lot of questions that will follow, but generally the principle will be the same. So we'll be looking at the bouncing ball here after. I hope everything is clear. And then from us, thank you very much. Kindly don't forget to subscribe. Don't forget to like our Facebook page. Everything, it's Nambane Academy. We'll really appreciate. Tell a friend so that now each and every one of us can be able to do well in this particular paper or in this subject, physical science. So thank you very much and have a lovely day.